Okay. So again, we're recording, so let me keep going. But again, here, so these are just some examples. Again, you have 4 is 2 times itself, which is 2 squared. 81, right, we have is just 3 to the 4th, and 3 to the 4th is 3 times itself, right, 4 times, so to say. In other words, you have 4 copies of 3, and you're multiplying them all together. Okay, so that's what we have here. Okay, now that's when your exponent is positive. Okay, a positive integer then. But now the question is, wait a minute. Oh, before we get to that, sorry. Here's a little warning I want to present. In the previous examples, the base, right? Can everyone see the slides?
Yes.
Yeah.
Okay, just wanted to make sure. Just wanted to make sure. Okay. So before, in those previous examples with 2 squared and 3 to the 4th, well, the base there was positive. You have to be careful if the base, though, is negative, okay? And why is that? Well, consider this example. What if I did negative 3 squared? Well, that's just negative 3 times negative 3, right? Which we know is 9. Okay, that's not so bad. What if I did this, though? Right? See the difference? We have here the negative 3 is in parentheses. That's not the case here. These don't mean the same exact, they don't mean the same thing. Okay? They don't. Basically here, we have negative 3 times itself. Here we have negative 3 times itself. Okay, in one case you're getting 9, here you're getting negative 9. So these are not the same. What I'm trying to say here, excuse me, what I'm trying to say here is that you have to be careful if the base is negative. That's really what I'm trying to say here. If the base is negative, okay? All right, so we have that. Good. Okay. Now we're going to get to negative exponents. And here you'll see that the base, the a, has to be non-zero. Okay, so suppose we have a non-zero number and a positive integer n. Okay, what does it mean to take that number and raise it to a negative power? It means you do 1 over. So you do 1 over a to the n. And a to the n we have seen already because, again, the n is positive. So a negative exponent, you do 1 over. We have that. And it turns out we'll actually see why later. I'll get to prove it for you guys. A to the 0 is actually equal to 1. Again, this is assuming a is not 0. Okay. And here, again, I just threw in some examples for fun. So we have 2 to the negative 2, for instance, right? That's just 1 over 2 squared, which is 1 over 4. And then I threw in this example as well. Okay. Again, these are all on the slides that I posted on Blackboard, so you should have this already. Okay. All right, so that's for negative exponents. But now again, like I said, what happens if your base is 0, okay? Well, if your base is 0 and the exponent is positive, that is, if it's a positive integer, okay? In that case, you just have 0 times itself n times, right? And which, of course, is going to be 0, mostly because 0 times anything is 0. But again, you have to be careful because what if you have 0 to the negative power? Well, that's not defined, mostly because you can't divide by 0, okay? So you can't divide by 0. So 0 to the negative n, again, n is a positive integer. That's nothing. It's just, it's not defined. In particular, 0 to the 0 doesn't exist. It's not defined either. So 0 to the 0 is also not defined. It's nothing, okay? It's not 1, it's not 0, it's nothing. Now we get to look at products, okay? So here what we're going to see is some rules you probably have seen already. If you haven't seen these, that's okay. I know, again, I'm not doing too many examples, but if you want to see more, you're more than welcome to see me during office hours. So let's suppose we have a real number, okay? Well, let's consider this. So if you have a to the 3rd, right? I don't know what a is, but it doesn't matter. And you have a squared, right? Let's say we want to multiply these. Okay, well, a to the third we know is this, right? In parentheses, a times a times a. A squared we have is a times a, right? Now the parentheses we really don't need because multiplication is associative, right? Which means you can multiply, you can use parentheses in any way you want. So really, if I take these away, we have this, okay? Which is, since you can see there's 5 copies of a, this is a to the 5th, and 5 is 3 plus 2. Okay, that was all fancy, but what really just happened? Really, we just added the exponents, right? So in other words, if you have like bases, you're going to add the exponents. And that's really what I'm trying to say here. So for any number, any real number, you have 2 integers, right? You add the exponents if you have like bases. Also, the book actually makes this convention, and I should say it here. We're implicitly assuming both sides here are defined. Okay? So if m and n are positive integers, there's really nothing to worry about. But if m and n are negative, okay, then in the background we have a is not 0. Does that make sense to everyone?
Yes.
I think that'd be yes. Yeah, I hope so. Okay, let me just see something real quickly. See if anyone has any questions. Okay, let me see. Oh, there we go. Yeah, I think everyone's okay. Yeah, there's no questions, so okay. All right, so now we're going to go to the next slide. Oh, no, excuse me, we have an example. Just present it from here. There we go. So we do have an example. As you can see, we have, I just threw in just a quick example, 5 to the 4th times 5 squared. Again, you could just, multiply those, and you can actually get the actual product easily. But again, you don't have to. You could just add the exponents, and you can write it as 5 to the 6. Just an easy example. I figured that'd be cool to do. Okay. Now we have products. Now we have quotients. Okay. So again, let's consider an example to see what's going to happen. So we have a here is not 0, right? It's a non-zero number, right? If we had a to the 7th divided by a cubed, right? What's a to the 7th? Well, that's a times itself 7 times. A cubed is a times itself 3 times, okay? But now we know we can cancel. Again, a is not 0, so we can do a little bit of cancellation. And what ends up happening is you lose the 3 a's on the bottom, and 3 a's you're going to lose from the top. What are you left with? You're just left with 4 a's, right? Which is a to the 4th. Okay, so what does that give us? Well, notice that 4 is 7 minus 3. So in other words, we have a to the 7 over a cubed is a to the 7 minus 3. So in other words, we subtracted exponents. So for any non-zero real number and integers m and n, okay, when you divide like bases, you subtract the exponents. Okay. So you probably have seen that before. Again, here we have to assume a is not 0, right? Because we're dividing. And I just threw in one example here, 5 to the 6 over 5 squared. Again, it's going to be 5 to the 4. And why? How do I know that? You just subtract the exponents. Okay, so that's what we have here. So 5 to the 6 over 5 squared. Again, all we're doing is we're subtracting exponents. Okay, now I said I would prove a to the 0 is 1, right? If a is not 0, well, I'm going to do that now. So let's assume a is not 0, okay? Well, since a is not 0, I can write this. You take any non-zero number, right? Divide it by itself, you're going to get 1. Okay, that's cool. One of our earlier slides informed us that a to the 1